Hello, everybody. So, got a couple things to talk about tonight to finish up Module 6 of 8. So, we're getting very near the end. So, part of it is, well, I want to finish kind of early because you all have projects coming up and perhaps past due homework and things like that. And there's a lot to do. And for most people take more than one class at a time. So, I know you all have a lot to do this semester. So, hoping to finish up early, but we do have a few things to look at. There was a couple of data structures that I want to talk about, just some pictures on the board. Not we're not going to sit and make them like the other day. Later, like after the break, we're going to start working on an example that uses them in situation. So we can see them in action instead of just those generic examples. But I'm not even concerned about getting that one finished. Just enough so that you can see how we would actually use it. Because I meant to take a screenshot today and I forgot to. Y'all know those y'all have seen those lists that say like what jobs to look for from the degree and things like that. Has everybody seen those when you signed up for Ivy Tech?
Oh, yeah.
It's like with software development degree, you can do a bunch you knew this and right, like you will see on that list computer programmer and software developer are both on there, which kind of indicates that there's a difference between the two. I wanted to mention that real quick. Other things like anybody getting the AAS or the most popular software development associate's degree requires that you take 2 project management courses. So project management's a field as well. Probably IT project management, not the broad encompassing anything. But IT project management, website design, some obvious ones, some not so obvious ones. That on that list, computer programmer and versus software developer. And yeah, if we were going to create a payroll calculator that uses a stacked data structure, a computer programmer, obviously that's the person that types the code. The distinction to software developer is software developer or software engineer. One of those would be the one that makes the decision on what to do, and then the computer programmer carries it out. When you see those lists and you see repetitions like that, and just to specify that the little distinction of the path you're on. So it's so and the computer science is all about optimizations and efficiency. So that would be the computer scientist would look into making that as good as possible for the equipment that it's going to run on. Right? Like if you were making it for something like a school, like we have here at Ivy Tech, they buy the computers in bulk. So you know that the software you make for Ivy Tech, you know which computers it's going to run on and can optimize it for that one. So the computer scientists would do that. The software developers and software engineers would be like the project managers that make the decision on how it's going to happen. And then the computer programmer is the one that actually does the typing. And obviously there's a lot of overlap between those because you would be hard pressed to find a team where the software developer or software engineer, depending on which one you have in the situation, doesn't type code as well. Or maybe looking to optimization. Some of those background things that we were talking about, the thinking and planning, that's a big part of software development, which is why you all have to take 2 project management courses for the degree. Which name just disappeared? Was that you, Nathan? You come in twice and then.
Yeah, I was actually on my phone. I was running late today, but I still wanted to make it before attendance.
Okay, I thought I saw your phone already leave, and then I was like, "Oh wait, did his phone not leave yet?"
Yeah, my phone left, and I just finally got home. Sorry.
Okay. No problem. I was just making sure somebody wasn't losing connection or anything. But just a quick note there. So that's what we wanted to make sure and at least introduce the data structures. It's an elective that y'all can take later. Instead of 268 is algorithms and data structures. So that's the planning and stuff. is up there right around the level of the 2 project management courses y'all have to take, which means a lot of thinking and background stuff and figuring out what the best way to do something is so that you can tell the programmers on your team to do it. There's 2 more. I guess we can start by talking about those because they're pretty common ones. Well, one we've been using in pictures for a while. Several pages of tree stuff. I just want to talk about one in particular because the diagrams I usually use involve putting a heap together. It's kind of complicated, so we don't usually put in the effort unless we know for certain that it's going to would be the one to work with. Has anybody seen Big O in any of their other computer classes? Big O notation. One O of N, O of N squared. I guess O of log N, natural out of the other log. That's why they always spell that out. There's too many N's. O of log N, N squared, and so on. First one would be N factorial. Anybody seen that? So what this is big O is the measure of efficiency loss, the measure of loss and efficiency. So as your input increases, as input increases, I'll just draw an arrow. As your input goes up, efficiency change. As we have more inputs, obviously we're going to need more RAM. And if we go from 10 values to 10,000 values, we're using more resources. It's going to take longer, but is it just linearly longer? That's the best we could do, right? If we go from 10, if we can do 10 inputs in 10 milliseconds, and then we go to 10,000 inputs and it takes 10,000 milliseconds, right? We didn't lose any efficiency. That pretty much never happens. That basically never happens because other things are going to get in the way. We're using more RAM. We have more stuff to move through the CPU. It's going to obviously with that time increase, other software on the machine might need the resources during that time. So typically, if we started at 10, let me do a smaller one. Let's do 10 to 100. If we have 10 inputs and it takes 10 milliseconds, and we jump to 100 inputs, we did 10 times as much, but it's probably going to take more than 10 times the amount of time. It's probably going to take more than 100 milliseconds because of that increase. But how much longer? Are we looking at some value based on it? So if it's 10 times as long, do we have 10 times worse efficiency? We have 100 times worse efficiency, cube, squared, so on, all the way down to factorial level, which is kind of the worst that it can be. Depth first searches, that means we have to check every possible case. There's no way to filter it down ahead of time. No shortcuts can be taken. The only option is to check every possible option. Like brute force cracking a password. The change in efficiency is factorial level because there's so many more to check at every step. I'm sorry, just looking at the chat room. So this is a common thing for us. Just be aware of it. Computer scientists worry about efficiency. That's the biggest difference between computer science and software development or software engineering. Software developers and software engineers make it work. Or like we talked a moment ago, software developers and software engineers make the decisions on what's going to be done. So like our example later, we're going to start working on a payroll calculator. I'm more worried about just showing you how that stuff we saw the other day fits in than actually finishing the example. And y'all have a lot of other stuff. So we're going to start working on that. But software developers and engineers would make the decision. We're going to use a stack to process this payroll.
Would you have to be a programmer first?
Mm. Okay. Yeah, so kind of like software developers and software engineers are the ones that manage the programmers. So and then computer scientists would
experience, wouldn't you?
Preferably.
Okay.
Well, people ask for that, but that would depend job to job. But really, technically, that would depend job to job. Realistically, yeah, yeah, they're going to start you in a programmer, and with a software development degree, you'll move up from programmer to software to developer position quicker, because you're already on that pathway. But technically, there is a distinction, but also software developers and engineers write code, and then computer scientists will be looking for the way to optimize those codes. That's really expected optimization. So how as we increase the number of inputs, what happens to our efficiency? Heap is right here. If we go from 10 inputs to 100 inputs, and the 10 inputs took us 10 milliseconds, the 100 inputs would take us 100 milliseconds. We don't lose any efficiency. It takes a lot of work to do that. It takes a lot of code to get that straight. It takes a lot of confusing code to keep that straight. So we really weigh the value on that. But that is our as good as we can get as far as loss of efficiency. That's why we would use it. But it's a special kind of binary tree. In general, just be aware of the big O notation. If anybody's heading into a computer science pathway and just taking this class along the way, you will definitely have to learn how to calculate that for any given situation. And that's what you put in your researcher papers. You're probably used to, like, your English class looking at research from other sciences. Computer science is your calculation on big O. That's your research. Felt like I was going to say something else about that for a moment, but yeah, for us, for software development class, be aware of it. When you see that curly O notation, function notation, like we see in math class on the big curly O, that's that increase in input, and the efficiency change is our output. So a heap is the one as good as it gets. It's a special kind of binary tree. What's this black marker look like? My black marker is done for, but maybe the one in the room here works. Oh yeah. Special kind of binary search tree. The ones we looked at last night. Remember, at most 2 branches off any node, and smaller things go to the left, bigger things go to the right. So we have the order to them. But we add to it special kind of binary search tree with root being the smallest or largest. We could go either way. So instead of just taking our first element and making that the root and building everything else, we need to check through and find what ours, either our largest or smallest is, one of the extreme of. When we find that, the root's the smallest or largest of any node. And then there's a downward one as well that is really hard to put into words, and I don't think this black marker is going to work either. So I'll switch to blue. Maybe the blue works. So I wrote an example, so I wouldn't have to think of it. Okay, now. So for a minimum heap, I'm going to be able to read that. Let me write bigger. A minimum heap which obviously the smallest would be the root and the minimum heap. Our root is the smallest element. And then off to the sides, we have a 7 and a 9. So it's still following that smaller to the left, bigger to the right thing. 6 and an 8. Let's put a 10 here. Yeah, just 10. So almost a heap. And is perfectly balanced, well balanced. Oh, full. I'll put that. It's full. So notice we have one here that's not a binary node. We have one branch off of it. A heap does have to have both branches. Void and none. We're in Python, so none, but in other languages, we usually use the word null. Those are data types. We don't think of it. We always think of it as empty until we need them. But they are an object. It's the object-oriented representation of nothingness. And depending on the situation, we'd want to use one or the other because we have to have our tree completely full. Every node has to have 2 branches. And I'm going to stop drawing it there, but no matter how big the tree is, we look at the root and then one more element, and we can jump anywhere in the tree. So it's like check, check, jump anywhere in the tree. Check this node, jump way over here in the tree. Check this node, and that takes us right there. So that's why it has that optimal efficiency. We just need to, it's very, very, very structured as we go smallest at the top. So we have order going this way and this way. And once we check that first one, we can make jumps to other ones. And in the worst case scenario, we might have to check 2. Check this one. It's like not quite enough information. Look at the 8, and then we can jump 80 rows down that tree and 6 branches over.
How can you do that?
Very, very highly organized pattern. So we're not going to get into the code. The code's we can look at the code real quick. If we can find one in Python. Let's see. Code for a heap in Python. Oh. Well, heap is built into Python, so we could just use that. Heap queue. Implementation with code. Oh, no, they're just using heap queue. It might be hard to find it in there. Usually we can find it. We see it in C++ or Java most often. Code for a heap, so we might have to look at logic in a different language. But since Python includes a heap in the default installation, I'm pretty sure all the tutorials are going to be like that one. Like you say, import heap queue and then just start calling methods from it. So that would be one answer to your question today. That's the nice, easy question to answer to your question, especially if you're heading down a data science route and might need to process insanely large amounts of data very quickly from time to time. Programming probably has it. If you haven't used this site before, it's pretty good. They usually have Python, Java, and C++. Descriptions. So here's the method to put things in order. So really looking at the code, but notice we have left and right as well as the index. So we have numbers to work with the pattern, and it seems to be spread out. If there is no node, create a new node. That was that empty spot that we filled in here. Filling in is the amount of completed code. Oh, they do have it in Python. So get your largest, so they're doing a max heap. Then we have left and right. And it's 2 times our largest plus 1 and 2 times our largest plus 2. And see how we're building up a complex mathematical pattern that way? Obviously, you could copy and paste this code, but you would probably want to spend quite a while studying that code and making sense of the pattern and how we insert things and remove things and traverse it. But if we're smaller than the thing we're looking for and the large, yeah, it gets into index, and the spot in the array we're at is smaller than the stuff to the left, and a complex mathematical pattern. But you can see it right there on Programmies. They have a good site, good tutorials, and usually in several different languages. This particular one, it's not going to help to look in the other languages, but you would want to stare at that for a few minutes and kind of make sense of what the code is doing in particular. But in Python, it's already built in. We just use the one somebody else already built. A large heap, a max heap is similar. Example, I think I filled it out completely. Max heap. Our largest element is the biggest one. So then we take that and then we build our pattern off whatever goes in there. And then those are used as indexing to wrap around. In Python, we can just put the index number and see all those other ones, examples there. That index has to wrap around, so we have to do it index mod, whatever size it is. But in Python, if we have elements, we can set it to wrap around or use the positive and negative numbers. There's little tricks to make it useful in Python. Let's see what I have here at an 11 and a 15. And as you can see, even making up an example is not one I'm just going to randomly do and throw in numbers on my head. You can't see that there's lots of scribbling because it took a couple tries just to get these numbers in the example that would work. 10 and 12.
Minus 15 work, right?
Which one?
15.
This pulls out of order. So we start by putting things in the binary tree and then we move them around. So once we put them in the binary tree, then we go down this way and we know what our largest branch is, right? Then we can start put that up there, and then whatever the root was, we shove into the place where it should be. Remember what was our example the other night? I think I had a 7 first. We just always use that 7 as a root. The 7 probably shouldn't. So if we were to do that in a heap, we'd swap that out with the 20 and then come back and put that where it needs to be in the pattern. So if that wasn't the max value, it still follows those rules. So it follows everything below that, and then we swap out the root for something explicit, and then find a way to shove that in there, which usually requires a well-balanced tree. This is another one I have here. We have to do a well-balanced tree first, and that's like the name sounds. So if our tree started like this, it's heavy on the left. So we got 3 there, 2 there. So well balancing, we'd probably want this to be the root. So we have 2 things to the left of it, however they would fall here, and 3 things to the right of it. So it's a lot more balanced. So we'd do this to our tree. So this is what we'd get from the other day. Then we'd do this, find our maximum value, swap that out with this, and then put the other one in where it needs to be. So it's very, very rigid pattern. It takes a lot of work. That's why we usually don't do this. Like, okay, other stuff is going to be good enough. But that's the idea of a heap. And you can see we can pull up the code and just stare and study the code for a while. It is It is not an intuitive pattern. It's a pattern that very, very intelligent people spend a long time thinking about exactly what the machine is doing in order to do what the machine does. Usually we adjust code so that we can put human style thought into machine format. A heap is machine style format. So we have to adjust our way of thinking to really put those together. It's optimal per machine. But it's the fastest possible way. So things like RAM that we're going to have a lot of would be there. I also had spanning trees and graphs. Those are slightly different structure. Connect all the nodes, basically. So if we had a tree here and then started drawing more lines to connect all of these every node is connected to every other node, or something that is approaching that, then we would have a spanning tree. But again, just introducing the concepts. Does anybody have any questions about heaps before I erase this? Talk about one more. One that would be used more often, that we fall back on more often if we have to write it from scratch, because it doesn't take nearly so complex of nearly such complex algorithms to put together, would be hashing, or in particular hash tables. Hashing is the act we do to get our key. So key value pairs, like tables, right? Everybody seen, we draw key and the value we want to store. The words we use in the dictionary, but a Python dictionary is not a key value pair. A Python dictionary is parallel list. It's just two lists, and we keep one that's keys and one that's values. Also, the keys here would be integers. So let's say the value we want to store is like a 5. So different tables. Well, I'm gonna pause at this point, and this picture here of just what a table looks like. That looks an awful lot like some of the chips. I'll draw a dual inline post. We have different styles that our chips can come in, but the dip one, it looks an awful lot like that table, right? We have something coming in and something else going out. And that's how those work. So let's look for a dip. Okay. Dual inline post. 62. That'll work. 6-1. What is that? No, I just want to see the picture.
Right click.
That'll work. So this particular one uses 8 bits for address and 16 bits for data. This is a RAM chip in what's called dual inline post. You can see the name. You've probably seen this type of chip before, right? You're probably used to the flat SMT mounts. There's several different versions. This would be for, like, where would this be used? This would probably be used for like a car radio, maybe 10 years ago, where we only need to store 5 or 6 things or build stuff, but it's RAM. The form factor it's in isn't what matters. It's what's inside of that black case. If you never cut one of those open, there's like a purple gooey substance inside. That's the silicon. The black is just to dissipate heat. That's just plastic. Black's a good color for it. But let's see, this first one's ground, and then the rest of the next 8 pins are inputs. So we would send some address in there. So we would send an integer in there, and then coming down here, and then around on the other side, most of these would be the output. And as soon as we send an address in, a signal in those address pins, we get the data flows out the other side, kind of like the speed electricity moves. And I wasn't talking about that arbitrarily. That's the effect we get from a hash table. Grabbing our things out of RAM, a heap's going to optimize RAM. It's going to optimize how we're using RAM. But a hash table, we grab things from RAM almost at the speed of electricity. We say what address we want, and that data just immediately comes back. And let's say we have a few data points. So let's say we want to store a 5. We need some sort of algorithm that can make a key out of our data. So a 5, I'm just going to make something up. It'd obviously be a lot more complicated than this. They typically are polynomials with 32nd power on the X, sort of thing that a computer can do, but I'm not going to calculate that on the board. Let's do a much simpler polynomial like 4x squared plus 5. 5x, a nice little quadratic. So this is our thing. This one would probably not actually work. We'll talk about conflicts in a moment. We want to store 5. So we plug that in here. 4 times 5 squared plus 5 times 5 is 100.
125.
125. So then that becomes our key, which is also the address on the RAM chip. So in order to retrieve it, we don't use a big long variable. We store it as the address on the RAM chip, or collection of RAM chips. That's why Twitter uses this, or X now. That big, massive pool they have to dig through. People want to find those common related tweets quick. So they use hashtags to create the key, and then that organizes into, in their case, it organizes onto which collection of RAM chips it goes to. And then there's another one that pulls up a particular tweet, but it gives us the fastest possible speed to get something out of RAM, because we're storing it like variable names that are useful. Instead of using a useful variable name for a human, or wherever the computer wants to put it, depending on the algorithm it's managing RAM with, we use the useful name of the address is the return value, and it's calculated from the value itself. So maybe we also have an A, a capital A, which would be 65, right? Probably need a calculator for this one. 4 times 65 squared, which I have no idea what that is off the top of my head, plus 5 times 65. Probably find the rest of them, but got a calculator on the computer. Calculator is a computer, right? Oh, yeah, I got it. 17,225. Thank you. I haven't even got the screen shared yet to pull up the calculator on here. So that becomes the key of where we store the letter A. So you can see we're going to run out of RAM spots pretty quick when we get up to work. So that's why we have very, very complicated algorithms, not simple ones that we can work quickly in class. There's also conflicts, because what if we have the number 65? We already know what that's going to give us, right? Yeah, but that's a problem because we can't store 2 things with the same key. So we do have to come up with algorithms that are complex enough to avoid conflict. We can't have 2 things with the same key, or have some backup method to deal with those. That's where those get complicated, but usually this is a lot easier because we just put together an equation that will turn whatever data we have into a number, and then we tell the computer to use that spot in RAM. So it has the advantages of usefulness of a variable like we put in code, but still direct control over RAM of the sorts of the reason we use variables. Like we're never going to remember that we stored a 3 in bit starting at bit 28,413 in RAM, and the 3 takes 8 bits to store, or if a 3 takes 32 bits to store, and it starts at whatever number I just made up there a second ago. We're never going to remember that, so this gives us a useful way to do that. And the picture looks a lot like a chip. I like to draw that there because it gives us almost electricity speed, because then we just turn on these. Then we turn on the binary number of that. We turn those pins on the chip, and the data flows out the other side of the speed of electricity. So very, very fast retrieval. That's where hashing is this, coming up with an algorithm that will build all our keys without any conflicts, or maybe deal with the conflicts nicely if we have them. And I like to show that because hashtag has become part of our language. Everybody knows what a hashtag is, and that's why something big and big as complex as Twitter or X has to have those things. I have more notes on data structures. There's a lot about them. SDEV 268 would be the class if you wanted to dig a little bit deeper into them, or are planning to transfer to a 4-year university where you will definitely have to take data structures class, and would like to transfer in one for Ivy Tech prices instead of other colleges in Indiana, because Indiana has some pretty nice colleges, and they know it, and they will charge appropriately for them. Some of the some nice engineering schools in Indiana, and yeah, they are happy to charge what they feel their value is. But yeah, we have a data structures class here that can transfer to other schools too. Lots of things to talk about on those. So any questions about those? Just out of a conceptual thing, and that's the idea of data structures, right? Those two sum it up nicely, where a software developer would want that. Right? You all have to take 2 project management courses, which kind of implies that software developer, like software developers and software engineers, are managers over other people just writing the code. So that's decision making. You would tell the coders to make a hash table, or make a heap, or whatever is most appropriate for your project. We'll see a small example of that later. And we probably won't finish it, because at this point in the semester, I'm more concerned with you all having plenty of time to work on projects, and there's just a few lines we need to see in there to be like, oh, that's how that fits in, as opposed to those completely generic examples we saw the other day. Before we do that, though, we do have something, the next step in Django to cover, which some of you all will be quite happy with, and I don't know why I didn't put this in the emails that I've been replying to the last couple days. Is Cage here? Cage isn't here. CJ, this will apply to you. I don't know why I didn't say wait until Wednesday's class. But the next step in Django is to deploy it to the internet. So not running on a local virtual server, let's go put it on an actual server and run our code from there. So there's a popular site that will allow 1 free account, which will be enough for this class, or most people have more than 1 email these days. Right? If you need 2, like 1 for your homework, 1 for your final project or something. PythonAnywhere.com to be right at the top of any searches for it. And I need to get Zoom thumbnails out of the way.
They would be able to change the code, right?
Yes, we're getting ready to look at that. So
we would just need to delete the code or homework and final project views one email.
Oh, that would work, yeah. Yeah, if you've got it ready to go, then you'd have it on your local machine. Just as soon as I get that graded, I'm getting caught up on grading. I got a whole lot done yesterday, and then there's some stuff that's kind of locked, so it looks like I'm not grading it about halfway through. So I should be done within the next day or two on grading. I have an account, so I'm just going to go to log in. Okay, good. Looks like Google remembers it. So, whoever set up their site could probably benefit from a UX class, user experience, or UI, UX. We have user interfaces, but we also have user experience. It does not look like it, but this snake up here is the home button. So anytime you get lost in the pages, this is the home button, but it does not look like it. Consoles, we can have several consoles. You want to limit how many you have open. By default, it should be 5. So when you set up your account, you can have up to 5 consoles. You can change that, but really, when you're done working with a console, make sure you close it. So it's a bash terminal this time. So Linux and Mac users will code right at home. Windows users, you might have to do it. Well, really, the only thing that's going to change is how you set variables. Everything else comes from Python, which is cross-platform. But the way you set variables is different. But we've already seen that in 2 different, a couple situations this semester. So you can get to all your recent consoles, but it's best practice just to close them when you're done. That's just the word exit is the easiest way to do that. Access the files. Jupyter notebooks, we're not going to use that. And our web apps will only have one with the free account. Up here at the top, same labels. So all the consoles we have open, it's going to be a bash console. If you get to close it, you can just hit the X here and close it afterwards. We'll do that again. Files. Let me click on some random file. Let's say colorful. I'll just open. I want to open the latest copyright. Oh, I did a tipping calculator last time I taught the class too. So in the tipping calculator under views, this looks familiar, but notice we have an IDE. This is not a general IDE. This is an IDE that was designed to work on Django projects. So it pretty much only knows Python, HTML, and CSS, and has some extra benefits by only knowing 3 languages instead of trying to work with every possible language, which is really, really nice. So you can just type your code here. You don't even have to upload it. To answer your question from a moment ago, you can just type it right here. And when you're done, notice the breadcrumbs. If we go here, if we click anywhere on the breadcrumbs, it takes us back to the regular files thing. I'll do that again. So from the IDE, just click on your breadcrumbs. There's your home button. Does not look like a home button, and it's not labeled. But if you click on any of the breadcrumbs, it comes back up here. Web's an important one. This is where most things are going to happen. After you make any changes, the server is still going to push out the old version until you come over here and click this green button. They say reload, but reload is what we think of on the back end here. This green button is the push the new version out. Users are still looking at the old version, and you click that. I'm going to go in here. I think I go here. Reload that. Okay. Oh, I guess I didn't have to do that because I'm going to scroll to the bottom and hit delete. I don't know why I reactivated it if I was getting ready to do it. So when you set up your account, it'll look like this. This is important, but notice if I come over to files, I deleted the app, but all my files are still here. So you don't lose your files. So don't be afraid to use that delete button if you think something got messed up. could delete all of them. The cache and virtual environments creates the first time we run it, so we don't have to worry about that. Most of them will be automatic. These two down here were obviously some that I made, so I could just delete those folders. But I'll keep it for now. Just make sure you use something different, and then you don't lose your old code. So I can show that when we put a new app on, the old code is still there. Add a new web app. Your account doesn't support custom names, so you get this one. That makes the choice easy. But when you pay for one, you can go buy a good domain name and then just do the regular registration stuff here. Then what framework do we want to use? Here are the most popular Python frameworks. Your final project and your homework that you have remaining is in Django. But it looked like an even mix of people that did Flask versus Fast API. You'll notice Fast API isn't on the list. So the site's been around for a little while and they didn't update to Fast API when it was created a couple years ago. But for us, we want Django. Probably choose any version. 3.9 will work. We need to give it a name. I'll call it hi there. Oh, Python identifier. So hi underscore there. And we'll just print hello world for our class example. But really, what we're doing here is that Django admin start project. So if you have trouble installing Django, you can do that, create the project right here and use the IDE on here. I'll just put it in that directory, that'll work. And notice how we have a nice little wizard walk through instead of typing everything in the terminal. We do have consoles, so we could also type all this in the console, but it's a lot easier with the GUI. So what I did there is just that one we saw in the terminal, Django admin start project, hi there, and then set up the folders for it. Which usually doesn't take this long. Oh, the next button's not great. Oh, yeah, it is. We already looked at the buttons, but hopefully it looks like it's stuck. It usually only takes a couple seconds. There it goes. All right, so now we got that up there. Here's all the information about the page. Notice we got a new folder with that name, but the old folders are still there. So you can delete them or access your code back. If you look at the Django girls instruction, they have you bounce code off GitHub. But those instructions are out of date because GitHub and Python Anywhere both updated their security since those instructions were written. So those instructions are out of date. What you'll want to do is just use the upload button. So there's a nice big upload button right here. So instead of putting your code on GitHub and then bouncing it off GitHub to put it here, just download it and use this upload button. Or my recommendation would actually be to make the project here. Do that stuff we just did, and then come in here and use this text editor here. So like, hi there. New directory, all of that. Right there's one we're familiar with, the manage.py script. That's what does all the work, right? So now that we're in our project, we come up here and hit a console. Oh, this goes to the console tab somewhere. I think it's this button. There's a open a console button somewhere. Oh, there it is. Open bash console here. Yeah. I'm not a huge fan of their buttons, of the way they put their user interface together. The UI part works, but they could really use some of the UX part. And we get this big bash console here. And we're in that folder, you can see. It's bash, so we don't. I keep using PowerShell where we have alternatives on how we list directories and things like that. Because PowerShell knows bash commands and the old Windows commands and the new Windows commands, and we can code in our own and has a bunch of options, but bash does not. So we can see there's that manage.py script. So now we have the Python interpreter. Look at manage.py and start. Oh, then we need a name, right? Then give it a name. Greetings. Sounds like a name. We're just printing the word hello world. We're not going to get super fancy. But notice now we have that greetings folder. So I'm going to go ahead and close out of this terminal. Really what I should do is hit exit, type the word exit, and that shuts down this terminal. But I'm just going to go out of here because we're going to do that periodically. Note, see how we still have this other bash console. There's one running now. So if you go to the consoles tab, you can click and get back into it. So might not always need to shut them down, or when you're ready to shut it down, just hit the X. You're probably going to forget to type the word exit and come out and hit the X whenever you're done with it anyway. There's a limit on how many consoles you can have. But if we go over to files now, then the Hilo project and the greetings app, we'll see a bunch of things we're familiar with. But we just added an app. What do we have to do before we add an app? What's the first thing we have to do when we add an app? Mm-hmm. Did y'all hear him in the Zoom call? Let's get the up button. Okay, breadcrumbs. Go back up a level, and in our project, there's the settings.py, which has that list of installed apps. And notice we also have the allowed host. What machines are allowed to use this? And localhost is not on there this time. We don't have 127.0.0.1. That domain we just set up is the only one that's allowed to run this code. And the only place we're allowed to run code from. Because if we're doing big projects on the web, there's a good chance we're going to connect to other things on the web. Instead of duplicating it ourselves. It's like it already exists. Let's just use the one that's out there. So we have to specify which ones we want. So add, you just pointed out, add greetings to our installed apps. Hit the save button. Come back out here, and then I just realized there's something we didn't check, did we? Go to web. Push out any changes. And then this does not open in a new tab. So make sure you right click and get your open a new tab. Otherwise, typically when you're debugging stuff, you want to see both the back end and the front end of that website, right? And we got our default Django message. So the project is running. It's already deployed. And we just need to update that app we made. So go back in files. So a different setting, but hopefully this is looking a little bit familiar, right? And a whole lot easier because we have GUIs and stuff to work with instead of just doing it all in the terminal. I know that was definitely overwhelming some people. We're in hi there and hi there. This one's optional, but I always take this option because if we're using Django, it's probably going to be a big project. Not necessarily in the classroom. We have very short amounts of time. But Django's usually for big things, which means our URL patterns list will get huge. It'll get massive very, very quick. So organization, a little bit of organization goes a long way. So I like to go ahead and put another urls.py script in every single app that we make. And then the list don't get quite as long. So we have 10 apps and all of them have 50 pages. Right? That would be like 500 items in this one list, which would make it hard to debug versus if we split it up to 10, whatever I just said, split it up to 5 different pages with only 10 items in each list, whatever numbers I just said. If we split it up amongst lots of small lists, it can be a lot easier to debug. So for path, we'll just make our home site. So the empty string, when we enter the domain name and then nothing else, domain, we can see it here with this one, right? Admin was already in there. So if we do domain name /admin, we'll get the login page, even we haven't created any users yet, so we can't really log in, but our domain name / whatever's in that string goes to this. Goes to this one. So let's just make the empty one into our actual app. So let's include, and this is where we have to type the address, the file path in object notation as a string, which seems really, really odd. Usually we have we type in a file path with slashes as a string, or we type the object like on the line above. We type the file path in object notation with the dots and no string, but whoever made Django decided that this one should be we should combine those two and put our object notation into a string. So we want the greetings folder dot, which they say slash views file, dot URLs. And then the .py is implied because that's a Python object. So we don't have to put the .py at the end. But folder. No, actually I want greetings.urls, don't I? I don't know why I put view. Yeah, I just want this. I don't know why I put views there. I'm trying to think ahead. That happens sometimes, right? But sorry, yeah, the greetings folder and the urls.py file, which we'll need to create. Why isn't it like that? Oh, another print. Is that what that was? Okay. And notice the red X didn't go away until I hit the save button. Now that it's saved, and come back, use the breadcrumbs to get back up to files. That's our project stuff. So now if we go in the app stuff, just like we saw the other day, we'll go in here and create a new file. And to create a new file, the hint's here, but people often overlook the hint. To create a new file, just enter the name. Girls.py, and then hit the new file button. Which goes right to the editor. So we need to import let me go back up. This exists now. Or come back up. Oh, can't leave. Come back up to this level. Yes, leave. I should have just copied it before we left. In our original URLs, we need this from Django.urls and import path. You're probably not going to remember what it is by the time you get to the other file, right? So whenever you're adding the path here, make sure you copy that. Copy that. I'll hit save so it doesn't give me that message again and again and again. And now go back to that greetings app in the urls.py script, paste that in, and then URL patterns. As one word is going to be a list that is currently blank. We'll fill it in a moment. But we've already seen that part, right? It's going a lot quicker than that last time too, right? It took you like an hour to get here on the last time. And yeah, we're getting close to break time, and I don't plan. Yeah, I plan on finishing. Yeah, we're about to take a break, so we're almost finished with just printing the words "Hello World." The part we're going to cover here. Hopefully, that's looking a lot easier than doing it all in the terminal. We don't have to upload and download stuff, and the instructions on that Django Girls tutorial, if you were working through that, those are out of date because both GitHub and Python Anywhere have updated their security since those instructions were written. So there's much much tighter security protocols on both sites now. So bouncing the code automatically is tricky, but there's a download file button on GitHub and an upload file button here. So that's probably the way to go since we have short time constraints and stuff. Oh, now we go in views. Actually, and same thing for a new directory. We need to make a directory, enter it here. So we need templates. Create that directory. Goes right into it, and then we can make I don't know, say hi.html. Make our template real quick. Super quick. Let's see. And let's just send something called message to this template. That'll be enough. Oh, maybe some text. Let's put our message in a level 3 header. Whoops. Notice how the predictive text fills in automatically. So you'll probably want to practice a little bit to get used to the new predictive text, but that's something that happens in every time we use a different IDE, because not all of them work exactly the same. I guess we could put a title up here too. Title, and then we'll fill that in with a title key that we send from our Django project. Things are already solved, right? Nothing new there. We're just doing it in a different space. There's our template, and it's called say hi.html, all lowercase, because we are running on a Linux server, so it's case sensitive. So Windows users beware. Mac users these days mostly have that option on by default. For a long time, that option was off on by default on a Mac. I think Windows and Mac both ignore case anymore, unless you just want to turn it off. But Linux doesn't. You have to be very, very careful with case sensitivity on Linux. Now we can go over to views.py and already imported the render method. So we can define a new function or a new method. Hello, that's a good one. I was trying to think of something different. I was thinking of Star Wars, our General Kenobi function. And it's coming from the client, so we have the request. Probably spelled that wrong, didn't I? I'm watching the screen instead of the computer I'm typing in, where there's like a 1 second delay. Request comes from the client.
Which spelling did you ask?
Oh, I was thinking that Star Wars meme with Grievous and Kenobi. Paradise, the little hello there. Yeah, we'll put General Kenobi in the address bar and get back hello. It seemed to fit without the a quick step away from the same boring labels to get used over and over again in generic examples. So we need our Python, so our data we want to send to the thing. We have a dictionary, so key value pairs, and it's expecting a title. We'll just call it, say, greeting here or hello here. It's a good title. And then it's expecting a message. Why hello there. I think that's the words from the movie. I haven't watched it in a couple years. And now we can send this. We can return. It's one of the big advantages of Django is we can yield stuff so that it returns in pieces. Obviously, we don't need to do that on ours, but when you have massive, massive things to return yield it instead of return it, so it goes back in pieces instead of all at once. And that way the user doesn't have to wait.
We cannot do yield.
Huh?
You said we cannot do yield?
We can.
We can.
Some of the other frameworks don't let us. Django is the big, more complicated framework. A lot of people like to go to Flask for small projects, but Django just has way more functionality. So we want to return that render method we brought in with the request, the parameter that came from the client, because that's how we know where to send it. There's a lot of computers connected to the internet. What template do we want to use? Say hi.html and all lowercase letters as a string, and then our dictionary. Hopefully everything there looks familiar. It's all stuff we've seen before, right? Just doing it in a different place, and we have this interface to work with things. Last thing to do is we need to go add the general Kenobi pattern to the URLs. So we'll have a path where we do the domain name / general Kenobi, general - Kenobi, and then that will I will call views dot. We don't have the include method looks at other folders. That's why we don't have to do include here. So we're in the same folder, so we can just say look at the views file and call the general Kenobi function as a callback. We don't want to run it yet. Django will decide when to run it, so don't put the parentheses on it. It's a function. A function is in a variable holding instructions instead of data. This is the starting point of that. How's that warning? Oh, we have to import views. Sorry. From dot import views. We do have to import that. From the current directory, import the views.py script. And all we can import is Python script, so the .py is applied. There we go. Save that. I believe that's all the changes, right? So come over to web. Oh, actually come over here. It's like, oh, it doesn't seem to work. Oh. We have to do this first. We would get a 404 right now. I can put it in there, but we haven't pushed out the changes. So it's still showing the old version. We can look at that. We should get a 404 error. / general Kenobi and page not found. So we haven't pushed out the changes yet. That would have been a better example than just spamming the reload button there. So make sure you hit the green button on the web tab when you're done. And now if we reload, we should get an error message because we took away the blank string, but it's expecting to see General Kenobi somewhere. So if we add that to our address, we get our message.
About the General Kenobi, what was the admin /
Go
back to the website.
Oh, so admin is already included for us. So we have administrative functions. The Django Girls tutorial digs into those pretty quick. You set up a username and password, build some database stuff. Mostly it's user access and authentication stuff. Anything we do from admin, mostly, except for, yeah, it's where we can restrict stuff. So that only certain people
Can
can log.
we do that?
Huh?
Can we do that?
Yes, so the Django Girls tutorial digs quite a bit into it. Those ones that I've left in purple from the site, if you want to look at that, I believe it is called admin. A couple people are working through that. Is anybody that's working through that is the chapter called admin? We can look real quick,
Yeah.
but that is automatically included. You'll recognize.
That's Django admin.
Yes, thank you. Yes, so if you look at that chapter, it will show you how to set up users and all of that stuff. but we're under tight time constraints, so introducing Django, I want to get some stuff on a page working, and then y'all can get lost in the weeds with Django later.
To get into that website, we can use username admin. That's what admin is for.
You have to set it up. You have to set up an account. So if we go to Ivy Learn and the tutorials that were in the statewide course shell, one of the chapters is about that. Let's see if we can find which one real quick. This has. I think it was the original module 5 link. The stuff in purple might be that chapter, the ORM, but
That's fine. I found it.
you found it?
I found the website.
Okay, yes. There's some instructions right there to it on the thing, but it's one that in past runs of this class has ended up confusing more people than not and running out of time. People end up not getting the project finished. That's the big one that was get confused and then straightened out is one thing, but when it prevents people from getting their project finished and our time constraints, that's a different ordeal. So we want to be able to finish our projects. But that's all we need to do to deploy this out to the internet. Because now our site's out there, or probably a more interesting site than that. You grab that app that you made a couple weeks ago, those who did that, or those who followed the blog tutorial on Django, that Django girls, and bring your code over to there. And a lot of things are a lot easier that way than doing it locally. And in a sense, until you give people this address to it, you can debug there. So if nobody knows to check that particular URL, you're still free to debug there. They're not going to see it until you share the address with them. Anybody have any questions about that deployment? And then that is how you'll turn in this week's assignment and the final project. So this week's assignment will be something small, probably something like what we already did, and just set up the deployment, and then the final then you'll put your final project on there. And I will not have access to see the code, so you will also need to download it and put the final project on GitHub. Which
There's a little download beside
the files, yeah.
Yeah.
So it's like each file by themselves download. It'd be nice if we could download these. There's a way to, and oh yeah, I remember what it did. Zip it. So if we open Bash console here at the top level, list it out. Is zip in here? Okay, cool. Zip is in here. We don't even have to go with the tar that we normally have on Linux. We can zip that hi there folder. And that's it. I haven't used this in a while. Make zip file is O. Where's the make zip file? Options and I need dash B. Zip dash B I there. So I'm gonna use it. Zip a folder in Bash. I remember the commands for tar. Oh, dash R. Oh, yeah, that's right. Output file first. I've done that backwards before. So zip dash R, the name of what the zip's going to be, and then the input. So let's try that again. List out what's there, and then zip dash R, my files. And we want to zip my files dot zip, otherwise Windows won't be able to zip it. Mac would probably struggle if we don't explicitly say it's a dot zip. And then we want to put the hi there folder into it. There we go. See how we have that zip file now? So just zip dash R, a name, and remember the dot zip extension. Otherwise, your computer on the other side might not really know what to do with it. That's how they recognize it.
It's a different voice.
Well, that's how they recognize zip folders because of the dot zip extension or dot 7up or dot tar, one of the known extensions. This one is specifically for zip folders. So try to remember that.
There's .rar too, right?
Yes. I always just pronounce that. And then it said RAR. Or I think people say it that way too. Pretend like there's an O in the word. So now if we go in files, there is a nice little down button by that zip file. So you'll want to do that. Or remember that it's at the end of the recording right before we took the break on the first part of the video this evening. I could use a sip of coffee. Been talking for a minute. Anybody have any questions about that? That's kind of what your Django assignment is this week, is basically just deploy a site to the internet. And then we'll get ready to put your projects there. And remember, I can't see your file, so you do have to put you will need to download the files and put those up on GitHub. Because I can't bounce them over to that server, but I can bounce them off GitHub and run it on my computer without downloading it. So, which is what I'll do when I grade it. So it does still need to be in the same directory structure and everything that you create the Django project. Otherwise, 10 minutes sound good?
I was like, Professor, that was for the concurrency in Python assignment, or was that the tutorial assignment?
That's the Django tutorial this week.
Okay, thank you.
Yes, there's a bunch of assignments. So, okay, the Django assignment, the tutorial, the concurrency is something different. We will see that in a few minutes, but let's take a break first. I'll see you all in just a moment.